So this is what we are going to talk about in this class, this lesson. Okay, so you remember these equations, right? These were the three equations we gave last time for a foundation when the shallow foundation, when the failure type is general shear failure. Okay, this one for continuous or strip foundation, this one for square foundation, this one for circular foundation. Okay, so these equation, these three, if you remember, normally it should be 6. Okay, because these are for general shear failure, and we did also for local shear failure. Okay, but anyway, these equations of ultimate bearing capacity, they are not considering rectangular foundation. Okay, you see, don't make mistake, confuse continuous or strip foundation and rectangular foundation. They are not same. Okay, continuous or strip foundation is when the dimension of the longer size of the foundation is too much compared to the width, for example. Okay, if you consider the width of the foundation is B and the length of the footing, the foundation is L, B divided by L is between 0 and 1. If you have this situation, then you have a rectangular foundation. Okay, for strip footing, this L is way too long compared to the B. Okay, because L divided by B will be too long, too high. We gave the definition of this strip footing in the previous video. Please go back and check. Okay, but anyway, rectangular footing is not included in here. So, but in practice, we have many cases where we have rectangular footing. Maybe you know very well. So how will we deal with rectangular footing with the equation if we have rectangular footing? Okay, so all these equations do not take into account the shearing resistance also. Do you remember that if I take this figure, last time, or maybe the first time we introduced the equation, we said it was originally from Terzaghi, and in his assumption, in his formula, Terzaghi assumed that this shear resistance here above the foundation level, see the line between H and J, G and I. This shear resistance of soil here was not included, okay, which is not actually true, because this actually contribute, the shear resistance of the soil above the footing level actually contribute to the resistance. Okay, so we need an equation that will consider this contribution of the soil above the foundation level. Okay, so because of all this, people started to think, okay, maybe the equation need to be checked closely and check what we can include more. Some people came up with the case where the load on the foundation is inclined. For example, you can see this footing, okay, this is column. So in many cases, the load coming on the footing is just vertical, okay, coming perpendicular to the footing base, like this, okay, commonly in many cases. But sometimes it's not always the case. Sometimes you have load coming like this, inclined like this, or this way. Any is okay, okay? this way or this way. In that case, what will happen to this equation? How can you modify them to take account this inclined load? See, and also in some cases, it's not cited here, even the base of the foundation itself is not horizontal like this. Sometimes it's inclined. The foundation itself is inclined and load is inclined on this foundation again. So because of all this, Meyerhoff, okay, he suggested in 1963 that we should generalize this equation, okay, and adding some factors. Okay, here is the generalized bearing capacity equation. Okay, even this one also doesn't include everything, but at this step we can consider this as general. Okay, you can see C, N, C. These are here. N, C. It's like the same philosophy, same process. We have three blocks. This block, and this block. But we are adding just some coefficient to take account to load inclination, take account the shape of the foundation, and this kind of thing. Okay, but the general, you can see here C and C, C and C, Q and Q. You have Q and Q. Okay, 0.5 gamma B and gamma, 0.5 gamma B and gamma. Then the only thing that is new are these FCS, FCD, FCI, FFF. These. What are these? These are what we are going to discuss deeply in the rest of this video. Okay, so C prime is cohesion, you know already, I think. Q also, you know already, this one from the beginning. The effective stress, the overburden, like it is just gamma by df, okay, explained previously. This gamma here is the unit weight of the soil, and as I said last time, this gamma is not the unit weight of the soil above the foundation. It's the soil unit weight of the soil below this foundation level. Explain this many times. Okay, B is the larger the width of this foundation. Okay, B, or in case of circular foundation, it is diameter of the foundation. NC, NQ, and gamma load factor. It is not inclination here, just load factor. NC, NQ, and gamma. These are bearing capacity factor. This is a mistake. I will correct it soon. Okay, I will correct this. FCS, FQS, F gamma, S. F is standing here for factor. Okay, C is for cohesion, Q is for this Q, gamma is for this gamma here. Okay, to help you distinguish which group, this one or this one or this one. And S is standing for shape. Okay, so shape factor. Please remember that this is just a notation. In some cases, another professor, another person will tell you that, okay, the shape factor is just S, SC, SQ, S gamma. It's okay. It's just a name. Okay. It's just a name. So it doesn't matter what, but the meaning, you should know the meaning. Okay. So this factor will change according to the shape of the foundation. If you have circular footing, rectangular footing, and so on. Okay. And these are for depths. Okay. you can see that we have FC here. Here was S for shape, D for depth. Okay, if the footing is too deep or it is not deep at all. Okay, so adding what again? Inclination, load inclination factor. Okay, load inclination factor. This is what is added here. So this equation, as I said, it should be bearing capacity factor. I will change this and we continue. Okay, let me change it. Okay, so it is changed. So N, C, N, Q, and gamma bearing capacity factor. Okay, this FSS here, shape factor, depth factor, and load inclination factor, like this kind of load, if you have the load is inclined. So these factors are what we are going to discuss deeply in this lesson to see what are the value of these factors. You will see that there are a lot of authors that gave the formula, different formula to estimate these factors, okay, including Meyerhoff, of course. Meyerhoff, Vesic, Hansen, Dieber, everyone tried to give propose this factor, and some even propose factor for bearing factor to consider the inclination of the foundation itself, not the inclination of the load, but inclination of the foundation base. Okay, so anyway, this equation for determining these various factors are described in the following section, as I said. And the shape, depth, load inclination factor are empirical factor based on experimental data. Okay. Okay. So now you know the shape of this, and we are going now to discuss the value of each of these shape factors, depth factors, load inclination factor, and we are even going to include the base inclination factor. Okay, but before I continue, I would like to tell you that after this video, if you want to continue watching, continue following this program, please tell me. Okay, from now on, this program will be private, not public anymore. So if you want to continue, please contact me here by email. I prefer that, or WhatsApp also is okay. But this WhatsApp is changing, and as you can see, this one is new compared to the old one. This WhatsApp is changing. The email is permanent. Okay, or just make comment in YouTube, Facebook, anywhere, any of this. Okay, you can contact me if you want to continue this program. It will not be public anymore. Okay, so thank you very much for your understanding. This video will continue for those who want to continue watching. They can contact me. Okay, so I will continue this video, but you will stop here unless you contact me. Okay, thank you. Okay, let's continue.